In this video, we'll take a practical approach by examining how the orientation and tilt angle of solar panels affect energy production in different parts of the world. We'll explore the findings from a simulation tool, PV Watts, for 3 cities: Cape Town, South Africa; Damascus, Syria; and Jakarta, Indonesia. Cape Town, South Africa. PV Watts is an online tool that estimates the energy production and provides insights based on location, system size, tilt, and other parameters, helping users evaluate solar energy potential for residential or commercial projects. Let's begin with Cape Town, located in the Southern Hemisphere at a latitude of 34 degrees. The optimal tilt angle for solar panels here is approximately 34 degrees. When the panels face north, the ideal direction in the Southern Hemisphere, the system generates about 1,600 kilowatt-hours annually. East, 90 degrees, the productivity drops to around 1,280 kilowatt-hour. West, 270 degrees, the productivity increases slightly to 1,300 kilowatt-hour. This shows a reduction of about 20% in energy production when panels are oriented in directions other than north, highlighting the importance of tilt and direction. Damascus, Syria. Next, we move to Damascus, located at a latitude of 33.5 degrees. Here, the optimal tilt angle is roughly 33 degrees. When the panels face south, the best direction in the Northern Hemisphere, they produce around 1,500 kilowatt-hours annually. East, 90 degrees, the output decreases to 1,200 kilowatt-hour. West, 270 degrees, the productivity reaches 1,220 kilowatt-hour. Similar to Cape Town, we observe a roughly 20% decrease in productivity when the panels are not oriented towards the ideal direction. Jakarta, Indonesia. Now, let's look at Jakarta, located near the equator at a latitude of just 6 degrees south. The optimal tilt angle here is only 6 degrees. When panels are oriented north, they generate about 1,700 kilowatt-hours annually. East, 90 degrees, the output is slightly lower at 1,650 kilowatt-hour. West, 270 degrees, the productivity is almost the same at 1,660 kWh in Jakarta. The difference in energy output between east and west orientations is minimal, less than 3%. This is because locations close to the equator experience less variation in solar energy throughout the day. Why consider east and west orientation? So, why would we ever choose to install panels facing east or west? Well, east and west orientations offer a more evenly distributed energy output throughout the day. East-facing panels produce more energy in the morning. West-facing panels capture energy in the afternoon and evening. This helps match the daily energy demand, which typically peaks in the morning and evening, reducing reliance on grid power. It also prevents excessive energy from being exported to the grid, where it may not be economically beneficial. In conclusion, the ideal orientation and tilt angle for solar panels depend on your geographical location and daily energy needs. While the best direction is south, in the Northern Hemisphere, or north, in the Southern Hemisphere, orienting panels to the east or west can be a smart choice. It not only aligns better with daily consumption patterns, but also helps reduce grid dependency and energy wastage. Thanks for watching. Don't forget to like, share, and subscribe for more insights on solar energy optimization.